Okay, so we're going to go over composition of functions and composite functions. So there are 4 different kinds of a composite function, where you have your sum function, which is where you add your 2 functions together. You'll sometimes see it represented as f plus g of x, and all that means is f of x plus g of x, where you're adding them together. Your difference function, composite function, is f minus g of x, which is f of x minus g of x. Your product function is f times g of x, which is f of x times g of x. And your quotient function is f divided by g of x, which is f of x divided by g of x. And the only condition for that one is that g of x cannot equal 0, because you can't divide by 0. Okay, so let's actually look at doing some of that. So 1a says f of x equals 2x plus 1, and g of x equals x squared plus 2x minus 1. And we need to find our sum, f plus g of x. And then we need to figure out what that means when x equals 3. So I'm going to take my sum, and then I'm going to be adding my 2 functions together. So f of x is 2x plus 1. And then I'm adding g of x to that, so plus x squared plus 2x minus 1. And then my last step is to simplify, and I'm going to write it in exponential order from biggest to smallest. So I'm going to start with my x squared, and I only have one of those. I have a 2x plus 2x, and that gives me 4x. And then I have a positive 1 minus 1, and so that's going to cross out and give me 0. So when I add my functions together, I end up with an x squared plus 4x. So then, if I know that x equals 3, then I can plug in 3 for x, so I would get 3 squared plus 4 times 3. 9 plus 12, which is 21. Let's look at another function. We have f of x equals x squared and g of x equals 1 minus x. And we're finding our sum function when x equals 2. So I'm finding my sum, then I'm adding them together. So f of x is x squared. G of x is 1 minus x, so x squared plus 1 minus x. And then if I simplify that, that's like x squared minus x plus 1. All I did was put it in form from biggest exponent to smallest exponent. There was nothing to combine in that case, so I just rearranged it. So then if x equals 2, then I get 2 squared minus 2 plus 1. Plug in 2's for all my x's. 2 squared is 4, so 4 minus 2 plus 1. And 4 minus 2 plus 1 is 3. Let's look at subtracting functions. So in example 2a, I have f of x equals 2x plus 1 and g of x equals x squared plus 2x minus 1. Same functions as our first example. In only this case, I'm finding f minus g of x when x equals 2. So if I do that, then I know that my f function is 2x plus 1, and I'm subtracting my g of x function. So I'm subtracting x squared plus 2x minus 1. And I put it in brackets because I'm subtracting that whole function, and so I need to remember that as I continue to simplify. So the 2x plus 1 stays the same. I'm going to distribute my minus sign. So minus x squared minus 2x plus 1. let me just simplify. So I'm going to pull my minus x squared to the front. I have it 2x minus 2x, so 2x minus 2x cancels. 1 plus 1 gives me 2. So my subtraction composite function is negative x squared plus 2. And then it told me x equals 2, so I know that's like negative 2 squared plus 2. Well, 2 squared is 4, so this becomes negative 4 plus 2. And negative 4 plus 2 is negative 2. That negative was outside of the x, so that's why it didn't become positive when I squared it. If it were in parentheses, then it would have become positive. Alright, let's look at another one. F of x equals x squared, and g of x equals 1 minus x. And then finding my function f minus g of x when x equals 3. So I'm going to subtract them. So I get my f of x function is x squared, and I'm subtracting my g of x function, which is 1 minus x. And it goes in brackets, so I remember to distribute my minus sign. So I get x squared minus 1 plus x when I distribute that minus through. And then I'm just going to put them in order. So x squared plus x minus 1. And if I know that x equals 3, I plug in 3. So 3 squared plus 3 minus 1. 3 squared is 9. So 9 plus 3 minus 1. And what's 9 plus 3 minus 1? 11. So my function would equal 11 when x equals 3. Okay, so let's look at multiplying. Okay, so I'm given f of x equals x squared and g of x equals x minus 3, and I'm finding fg of x when x equals 4. Okay, so this is my composite function where I multiply. I find my product. So my f of x is x squared. My g of x is x minus 3. I'm going to multiply those, which is why I put them in parentheses. So let's distribute my x squared. So x squared times x is x cubed, and x squared times 3 is minus 3x squared. So my composite function is x cubed minus 3x squared. And then if x equals 4, then I plug that in. So 4 cubed minus 3 times 4 squared. 4 cubed is 64. 4 squared is 16. 16 times 3 is, how many it is? 50 something? That's 18. 48. 53. Okay, so 16 times 3 is 48. And then 64 minus 48 would give me 16. So my final function would equal 16. Let's look at a dividing one, because we've got one more type of function we're going to look at. So a dividing function is where we have f of x equals the square root of x, and g of x equals the square root of 4 minus x squared. And we're going to divide those functions. Okay. So if my f of x is the square root of x, I get the square root of x. If my g of x is the square root of 4 minus x squared, and I get that over 4 minus x squared. And then we have to figure out if we can simplify that. Which in this case we can't simplify because there's no way for us to take the square root on the bottom or on the top. So that becomes my final function. Division ones generally are the hardest ones to try to simplify. Let's do one more of those. So f over g of x, where f of x equals x squared and g of x equals 1 minus x. So my f of x is x squared. My g of x is 1 minus x. Can that be simplified? Nope, this cannot be simplified, so that's as far as we go. All right. So the last type of composite function that we're going to look at is f composite g of x. And f composite g of x actually means f of g of x, where you plug your second function into your first function. Okay, and our composite symbol is represented by this small circle in between them. So kind of when you write it, it looks like you're writing fog. But what you're writing is f composite g. Okay, so we look at f of x equals x plus 2 and g of x equals 4 minus x squared, and we're finding f composite g of x. What that means is that we are taking f of g of x, which means that instead of having an x, my entire g of x is going to replace my x in my original equation. So then if I do that, I see that I have this original x here. So instead of having that x, I'm going to have g of x, and g of x is 4 minus x squared. So that's what goes into my x plus 2. All I did was take my g of x, this 4 minus x squared, and I plugged it in for my x in my original equation. So now let's simplify. There's nothing to combine with my minus x squared, but there is stuff to combine with my 4 and my 2, and 4 plus 2 is 6. So f composite g of x would actually be negative x squared plus 6. Okay, so let's do a few more of those. Alright, so I'm given the same function, f of x equals x plus 2, and our second function, g of x equals 4 minus x squared, but in this case I'm finding g composite f of x. Okay, so it's opposite, so I'm going to take my g function and I'm going to plug in f of x for my original value, which tells me then that this f of x function is going to get plugged in for x in my secondary equation. So if I do that, then I end up with 4 minus x plus 2 squared. Okay, so then when we FOIL out x plus 2 squared, we get x squared plus 4x plus 4. And I still have this 4 minus out front. So then if I simplify, I still have minus x squared. There's nothing to combine with that. Still have a 4x. There's nothing to combine with that. And 4 plus 4 gives me 8. So I would end up with a plus 8. So my final composite function, g of f of x, would be negative x squared plus 4x plus 8. So let's do another one. So we're going to take f of x equals x plus 2 and g of x equals 4 minus x squared, and we're going to find g composite f of negative 2. So That's a lot of information. So g of f of x means g of f of x, but in this case my x is -2, so this is like g of f of -2. Okay, so we're going to start by finding this inside part, f of -2. So f of -2 means that I'm plugging in -2 everywhere that I see an x. So then I would end up with -2 plus 2, and -2 plus 2 would give me 0. So f of -2 is 0. So then this 0 is what I plug into my second equation. So g of 0 equals 4 minus 0 squared. And 0 squared is 0, so I end up with 4 minus 0, so that would equal 4. So my composite function f of, or g of f of -2 is actually just 4. When we go through and do all the simplification. Okay, so let's do that again, only f of g of x. So f of x is 2x plus 5, and g of x is 4x squared plus 1. We're finding f of g of x. F of g of x. Okay, which tells me then that my g of x is going to get plugged in for x in both of my problems. So that 4x squared plus 1 is actually getting plugged in for x on my original equation. So if I do that, then I get 2 times where my g of x is, which is 4x squared plus 1. And then I still have this plus 5 in the back. So all I did was replace my x. So now let's simplify. Distribute my 2 and I get 8x squared plus 2 plus 5. So then I still have my 8x squared, and 2 plus 5 is 7. So I end up with 8x squared plus 7 to be my composite function. It's starting to make sense. You guys want to do a few more? Okay. Alright, so if it makes sense, then we'll just get started. You're going to do page 88, 9 through 27 odd, and 37 through 47 odd. Okay, so the first few 9 through 27, those are going to be your sum, difference, product, and quotient functions. And then 37 through 47 will be your composite functions.